Hello, my name is Dave Detzler and I am the president of Clear Skies Coatings, and today I want to demonstrate one of the remarkable performance characteristics of our ultra low cure AdPro for TPO. Now TPO of course is used for, it's a material of choice for automotive front and rear fascias, and for good reasons. TPO is not very expensive, it's easy to mold, and has wonderful performance characteristics. It's both tough and flexible. But TPO, thermoplastic olefin, has one huge drawback. It is not readily paintable. And the reason for this is that TPO, like polypropylene, is a hydrocarbon plastic. There are only two elements in the polymer matrix, carbon and hydrogen. And the carbon-hydrogen bond is nonpolar. And paint adhesion to a substrate is usually dependent on setting up polar attractive forces between the polar groups in the coating and the polar groups in the substrate. TPO not having these polar groups make paint adhesion very, very problematic. Now there's two ways that we've learned how to resolve this problem. One way is after the fascia is injection molded, a flame is passed over the part and it partially burns or oxidizes the surface. And in doing this, oxygen is incorporated into the polymer matrix in the form of either carbonyl groups or carboxyl groups. And once we have oxygen in that polymer matrix, we set up oxygen-hydrogen bonds, and the oxygen-hydrogen bond is very polar. So now, once we've got the surface oxygenated, paint adhesion is not a problem. In Europe, this is the favored method, to flame treat TPO, but the process requires strict adherence to your process parameters. You have to have the part, first of all, it has to be done by a robot. A human being could never keep the process at just the right speed. So a robot is passing this flame, it's usually only about this wide, like this, and it has to follow the contour of the part, and those processes have to be tightly controlled. The ratio of gas to air has to be controlled, and a lot of other parameters. So the people that use this process know they need to stay on the process to make it work, because too much burning is bad, too little burning is bad. The other route is to use an adhesion promoter, but a specially formulated adhesion promoter, one that does not rely on polar attractive forces between the coating and the substrate. Adhesion promoters for TPO use polyolefin resin as part of the resin makeup, and that polyolefin resin will actually bite its way into the polyolefin of the substrate and work its way in there a little bit and become entangled. We call this molecular diffusion entanglement, and it's very effective. So what's the problem with using an adhesion promoter? Well, in this book by Rose Rentz and Yanov, they've got it. They say, using an adhesion promoter is probably the most effective, most robust, and most versatile process, but it's also the most environmentally unfriendly. One of the major concerns with the adhesion promoters is the high VOC content, volatile organic content. Typical adhesion promoter is about 80% solvent, and that solvent has to be dealt with. The solvents that's in the spray booth exhaust air and the oven exhaust air, you don't just send that out into the environment. You have to deal with it. You have to get that solvent out of the air. That process is known. It's readily available. You have to buy a regenerative thermal oxidizer, get it installed. That might cost you $50 million. And you have to burn off these solvents, and it might cost you another $1 million a year in natural gas to fire that thing. But it's known technology and it works. So if you want to have a process for dealing with the difficulty of painting TPO, you can use an adhesion promoter. It's robust, it's versatile, it's effective, and you just deal with the cost of dealing with the solvent emissions. So today we're going to use our adhesion promoter, and our adhesion promoter has 0 VOCs, 0 HAPs, 0 halogens, and no odor whatsoever, because this, although it may look like a liquid waterborne coating, it is not a waterborne coating. This is a colloidal suspension of powder coating particles in water. So the way we make this is that, first of all, we make a powder coating. Now, powder coatings are known for their performance, their durability, their strength, and for being environmentally friendly. But powder coatings need to be applied to a substrate using a electrostatic spray process. And for that process to work, the substrate needs to be conductive. And TPO is certainly not conductive. And the other thing is that powder coatings need to be applied to a relatively thick film thickness, about 2.5 to 3 mils. And adhesion promoters only need to be 0.2 to 0.3 mils. So a powder coating in a powder form is probably not a very good candidate for a adhesion promoter. That's why we convert our powder to a colloidal suspension of powder coatings, particles, and water. And they basically will not settle out even over a very, very long time. So with that, let's go ahead and do the gasoline adhesion test. So we have a panel ready. This panel, this is the black is the TPO, the gray is our zero VOC, colloidal suspension of powder coating particles in water, our AdPro, and the white is just a base coat, clear coat white. And you can see I've already scored the panel. I've used this template and a utility knife, made 11 cuts, horizontal cuts in this direction, 11 horizontal cuts in this direction, and then we're going to go ahead and use these special tape to check the adhesion. This is the crosshatch and tape pull adhesion test. Very common test in coatings, so we'll go ahead and pull that, and we get 100% adhesion. So at time 0, we have 100% adhesion. We'll go ahead and put it in this tray with gasoline, and we'll let it sit there in gasoline for 15 minutes, and then we'll come back and we'll pat it dry and retest it. And then every 15 minutes, we'll retest the adhesion. So our first 15 minutes in the gasoline have passed. We'll take the panel out, pat it dry, do another tape pull test on it, check the adhesion. Oops. And the adhesion is 100%. Now we'll put it back into the gasoline for another 15 minutes. % adhesion after 30 minutes. This is after 45 minutes total time. Still 100% adhesion. This is now a 75-minute test. Still 100%. This is 90 minutes. Still 100% adhesion. Still 100% adhesion. So now we've had a total of 2 hours in the gasoline immersion. We'll do one final tape pull. That will be the conclusion of the test. Oops. We still have 100% adhesion after 2 hours in tape test, but let's be a little bit crazy. Let's put it back into the gasoline for 24 hours. Let's come back tomorrow at 3:15 in the afternoon after an additional 24 hours and see what the paint adhesion is like, okay? Okay, so yesterday we did the 2-hour gasoline immersion test on a TPO panel that we had coated with our ultra-low cure AdPro Zero and then top coated with a white base clear, and it performed perfectly. After 2 hours there was no loss of adhesion, so we decided let's just go ahead and leave the panel in the gasoline overnight. And now we've come back 24 hours and let's see what the paint adhesion is going to be now. I have to get us a new piece of tape. You can see there's no blistering, lifting of the paint film. It looks absolutely perfect. Now we'll see what the paint adhesion is like. Oops. There we go. Also, after another 24 hours, we also have perfect adhesion. So we've created this ultra-low cure adhesion promoter that has 0 VOCs, 0 HAPs, 0 halogens, no odor whatsoever. Resolves all of the environmental problems with the adhesion promoter, and you still have the adhesion promoter method that is the most robust, the most effective, and the most versatile. And this may be a real technical breakthrough. In this book by Ulrich Poth, he says, many trials have been designed to replace these solvent-borne adhesion promoters with more environmentally friendly products, but the perfect solution is still to be found. I think we're about as close to a perfect solution for getting paint to adhere to TPO with this product.